first step is I'm going to start off here. I will probably just do this one first, just because we know that is u and v. So I'm going to set u equals minus 7x, v equals y, du dx equals minus 7, and then dv dx equals, well, that's going to be 1, so that's just going to give us dy dx. Use the product rule on this, so we are going to get u times dy dx, so that's minus 7x dy dx plus v du dx, so that's minus 7y plus minus 7y. I'm going to keep that there. So question 4, part 1 here, we're going to get 28x minus 7x dy dx, then minus 7y, and you'd already be getting method marks for doing this, plus 2y dy dx, and that's going to equal 0. And I think getting upstairs is going to get you 2 marks at least. Show that dy dx equals this. So what I would do is keep all the dy dx's on one side, and I'll plus the 7y and minus the 28x on both sides. So what we're going to get is minus 7x dy dx plus 2y dy dx, and we're going to get 7y minus 28x. Right. Alright, nice one. On you. So Nia, can you see we've got this 7y minus 28x, but this is 28x minus 7y. So we multiply both sides by minus 1. That's going to switch this around so it's be a bit nicer for us. So we multiply both sides by minus 1. That's going to become 7x dy dx minus 2y dy dx equals 28x minus 7y. Now if we take this dy dx out of the bracket, you can see this is going to work now. Dy dx times 7x minus 2y equals 28x minus 7y. And we can divide out by the 7x minus 2y now. So we're going to get dy dx here equals 28x minus 7y divided by 7x minus 2y, and we're done. Yep, that's good that you can see where you went wrong. That is important. So what I need to do is add a new slide to do part 2. So for part 2, each have x coordinate 1. The tangents to the curve at L and M meet at N. Find the coordinates of N. So we're going to let x equals 1. So if x equals 1, we're going to get 14 minus 7y plus y squared equals 2. I'm going to set that to 0 so we can solve it. I'm going to write that a bit neater. Minus 7y plus 12 equals 0. So we factorise, do show the factorisation. We're going to get y minus 3, y minus 4 equals 0. And then that means we know that y coordinate equals 3 or 4. Now, can you see we've got the dy dx here? Now we also know x equals 1 and y equals 3 or 4. So we can substitute any one of those in. So let's just choose n. So let's just choose y equals 4 and x equals 1. So we're going to get dy dx equals 28. That's 1. Minus 7 times 4 is 28. And that's 7 minus 8. But then we're going to get a gradient of 0. And well, that's going to be a stationary point, that one. Could be this point. Now let's try subbing in y equals 3. So dy dx will equal 28 minus 21. Let's say x equals 1 still. And that's 7, 1. That's 7 minus 6, which is going to equal 7 over 1. So the gradient is 7. So it says the tangents to the curve L and M. Well, if the... Right, so this graph here is going to create a line, but it's going to be a line like this. And this is going to be a line something like this, and they are going to meet at this point N.
I only did part A. I mean, the first part. I was stuck on this part.
Oh, okay. So does this make sense up to here?
Yeah, it does.
Perfect. So what we need to do is create an equation of a line. So for this one, let's see. Well, if we're going to use y minus y1 equals mx minus x1. Now, if m is 0, because that's the gradient of 1, what's going to happen here? 0 times all that is 0, and y minus y1, and y1 is, right, let's just say y was 4 here, right? So that means y minus 4 equals 0. So that line is actually the line y equals 4. And I believe that is a circle, some type of circle, isn't it? Because of the x squared and y squared, perhaps. So we're going to possibly get a line like this and a line like this, and we're finding... Oh, it does say a tangent, so actually it could be something like this and something like this, because it says tangents, right? But you get the idea. So that's the line y equals 4. We do the same with this one. Y minus y1 equals m x minus x1. Now we have m equals 7 for this question, and y was equal to 3 for this question. So we do y minus 3 equals 7x, and I'm going to split that up, and 7 times 1, so minus 7. Now you can see this is going to equal y equals 7x minus 4. And that's going to get us a bunch of method marks and answer marks doing that. So that's definitely going to give you an answer or a method. That's definitely going to get you an answer method. And then what do we do here? When those two lines meet, they have to equal
To 0?
I know, remember these lines are meeting, so imagine if that line is like this and this line is this, that means these lines are equal. So the line y equals 4 and this line are going to equal each other. So you're going to set this 4 into this. I'm going to write that here. So 4 equals 7x minus 4. So 8 equals 7x. So x equals 8 over 7, and find the coordinates of n. So that's one coordinate, x equals 8 over 7, and well, we already know y equals 4 there because of this point here. Does that make sense, people? That was 4x dy dx, right?
Yeah, that's what I got there.
Plus 4y, yes?
Yeah.
Okay, let's do that again because I forgot to do that. So yes, so that is 2x plus 4x dy dx plus 4y dy dx equals 0. Alright? This is what you got, right, on you? Oh, and I missed out the 4y from here. Right, is this what you got, everybody?
Yeah, that's what I.
Okay, fine. That's it. So that is my bad. So if we do, I would factorise dy dx out here, and then you would get 4x plus 4y equals 2x plus, oh, that's not equals yet, plus 2x plus 4y equals 0. Then you brought it around the other side. Then you brought these two over here, right?
Yeah.
Okay, wonderful. So, you get dy dx 4x plus 4y equals minus 2x minus 4y. And then we divide out by that. Dy dx equals minus 2x minus 4y over 4x plus 4y. Right, so if dy dx equals 0, we set to 0. If we multiply out by the 4x plus 4y, we're going to get 0 equals minus 2x minus 4y. Then you could get 2x 0 equals 2x plus 4y as well, right? But if it makes sense, if you used to bring this on this side and this on this side, you would get 2x plus 4y.
Yeah.
And it will still equal 0. So it's a bit easier to deal with positive. So this is acceptable. Now, is this the bit where you got stuck?
Yeah, this is the part where I got stuck.
Right, so find the two coordinates of the stationary points on the curve. So I think what you have to do is, you know that 2x will equal minus 4y. So x equals minus 2y. Okay? You happy with that? This GCSE, it's like
Did you just
substitute it into...
the equation?
Yes. So you sub that into here. So minus 2y squared. So sub in. Change pen. So minus 2y squared is going to give us 4y squared. Plus 4, that's minus 8y. That's going to give us minus 8y squared. Yeah, because that's minus 8y times y. And then we're going to get plus 2y squared plus 18 equals 0. So what are we going to get left with? Minus 2y squared plus 18 equals 0. Yeah?
Yeah.
Now if we rearrange that, you can see 2y squared equals 18. So y squared equals 9. And then we can square root that, so y equals plus or minus 3. And then you'll do the same, and I'll let you guys do that part. Substitute the y into the x. Well, actually, if you let y equals 3 or plus 3, you can solve it that way as well. So Amisha said, we've got this already. So actually, if you say y equals 3 and y equals minus 3, Amisha, why don't you just stop me from going such a long-winded way? And then I didn't even realise to use that. But that is the easiest method, and then you'll get y equals, no, x equals 6 and minus 6. That way. There you go, you would have even did that quicker. But all those methods are valid. I think that you look... Yeah, no, that is it. That's perfect. All that is perfect. How are we doing for time? Right, I'm going to let you do one more question. Any questions about that? I'm just going to let u equals x, v equals y squared, du dx equals 1, dv dx equals 2y dy dx. So essentially what we're doing is this, which equals, that's the probably correct notation, 2xy dy dx is this times this, and then that times that, plus y squared. So we're going to get 2xy dy dx plus y squared equals 2x. So dy dx is going to equal, I'm just going to write that, 2x minus y squared. We're going to divide out by the 2xy, so dy dx equals 2x minus y squared over 2xy. Stationary point at dy dx equals 0. So 0 equals 2x minus y squared over 2xy. So 0 equals 2x minus y squared. I'm going to write y squared equals 2x. Now because we've got a y squared in that question, sub into equation, we're going to get x times 2x, so that's going to give us 2x squared equals x squared plus 1. So we're going to get minus the x squared on both sides, x squared equals 1. So x equals plus or minus 1. X squared equals 1, the square root, no, x, we square root that, x equals, yeah, plus or minus 1. Or you're going to get x squared equals 1. Now if you get x squared equals 1, and we can put that into this. Y.
For y I got plus or minus.
What did you get?
I got plus or minus the square root of 2, but I don't think it's right.
Oh no, that's fine. So if y squared, because what we do is if we get, so this is what we know. This is right here. But we've got to be careful. So if we get y squared and we sub x equals, let's do 1 first into here. So we're going to get y squared equals 2, right? So we know y equals plus or minus the square root of 2. Happy?
Yeah, that's what I got.
Now, yeah, this is the important bit where you get a bit stuck. Now, when x equals minus 1, you're going to actually get y squared equals minus 2. Right? Now, this you cannot do without complex numbers. Yeah, because you can't square a number and make it negative unless you use complex imaginary numbers, I numbers. So that means we cannot include this, the x equals minus 1 as a solution. So it's actually x equals 1. So when x equals 1, you are actually going to get the two coordinates of 1, root 2, and minus 1, minus root 2. Any questions?
No.
No. So that makes sense because... No, so that's perfect. Now I think you should be feeling very confident about implicit differentiation. It just gets a bit harder when you use... You have to do it with trig values or with logs or exponentials. But it's just applying the skill, and then I'm confident that you get most of the marks. This question is very similar, just practicing that same skill. So, super work. And I think, yeah, that's good practice and consolidation for you. Yeah, no problem, Nia. It's just practicing. It is only because we are short of time that it's getting really we struggle. Well, it's because I have to pitch high, but then it's hard to pitch high until you have the foundations right. So it's not anything to do with your ability. It's me trying to rush, which is not helpful. And with a lot of practice, because you need a bit of practice and then it becomes easy. Right, Ella, how are we feeling? And Amisha as well. That's brilliant. That is good. So you can be a bit positive. Amisha, are we good? And Ollie, you did very well. So, like all students... Go on, Ollie.
Just say thank you.
Okay, yeah. You probably would only missed 1 or 2 marks here. And I can see actually a lot of students would have got stuck here because of this. When you get that y squared equals -2, and then you would think, oh, have I done something wrong, because that doesn't make sense. So that's a bit mean they put that in there. But okay, super work. That's over an hour gone. Well done, and you've learnt something, and you made progress, and your understanding is better. So well done, all of you. Take care, and I'll see some of you next week. Goodbye.
Bye, thank you.
You're welcome, Ollie.